Hi class, so on this part of the video, we're going to decide uh, how many reinforcement are we going to place on our footing. So although the process are the same, there are uh, there are slight differences on how are we going to do it, no, depending on what type of footing we are designing. So uh, just I hope you will just continue watching this, no, for in preparation, of what you will need to do. Okay, so let's start. Okay, so from sample number one, no, we determine the how much reinforcement that we need, by using the formula for the ultimate moment, So from what we've learned on the previous video, so we have four different ways, in order to use the formula for mu. First one will be the phi c sub f multiplied by d minus a over 2, then uh, next, mu is equal to 0 phi multiplied by 0.85 f prime of c a b, multiplied by d minus a over 2, c, phi f prime of c, omega bd squared multiplied by 1 minus 0.59 omega, wherein the f prime of c omega multiplied by 1 minus 0.59 omega is also called r sub n, which is also termed as the coefficient of resistance. And in terms of r sub n, we are able to derive equation number 4, equal to phi rn b squared. Okay. Then from those, if we use equation 4, no, if we use equation 4, for the mu, we are able to solve for rho, or the steel ratio, which is equal to the given derived formula. If we decided to use formula 3, we are able to know that omega is equal to uh, rho Fy over F prime of C. Okay? Ang rho natin is equal to AS over BD. Okay? So, let's go back to the problem that we're solving. No? Okay? So, MU, yung ultimate moment na na-solve natin from the previous problem is equal to phi multiplied by 0.85 F prime of C AB times D minus A over 2. So you may be wondering why I decided to use equation 2. It's ito yung pinaka-basic. And personally, this is easiest to memorize, actually. Pero I'm giving you the freedom not to choose what equation suits you. Okay, you may also wonder what should be the value for phi, we're going to use. Anong phi yung gagamitin natin, So if you can remember, ang goal natin kapag nag-design, is to make it yung tinatawag na tension controlled or under reinforced, Tension controlled yung ating design. We can use phi is equal to 0.9. That is from NSCP. Okay? So, yung mu natin, 802.43. This is in kilonewton meter, We multiply it by 1,000, and another 1,000 in order to make it Newton millimeter, Okay? Then, equal to 0.9 multiplied by 0.85, 27.5 A, no? 2,900 multiplied by 525.71 minus A over 2. We are able to solve for A as 25.64 millimeter. So yung A natin na yun, ito yun, no? Okay? This one. Okay, going back to the problem that we have here, no? Okay, so before we proceed to with solving the required steel area, no, we know na ang C, no, is a fraction of D, no, fraction of the effective depth, no. So tandaan ay ano, makikita nyo na we already use, no, 525.71 as our depth. No? Bakit? Kasi that is the minimum depth, no? Since we have to consider two ways here, no? Okay? So dahil alam naman natin na ang minimum depth for moment is 221.55, no? We can say na what more, no? Kung gumamit tayo ng mas mataas na value. We know na it's really safe, no? And to perform another check, no? Let's perform another check. Okay, determine the value of C, which is equal to A over B beta 1, no? 25.64 over 0.85. Ang beta 1 natin, that is also from NSCP. Ang C natin is equal to 30.16 millimeter. Okay? And then we know na C is a fraction of your effective depth. Again, like what I always say. So determine K, no? K is equal to 30.16 over 525.71, which is equal to 0.0574, no? C is equal to 0.0574D, no? This is less than 3/8 of D, no? Ang 3/8 D is ito yung tension control, no? So tension control. Okay? So let me erase this one. And kasi itong 3/8 D, yung na-solve natin kanina, that is C if we consider it as tension control. Okay? Ang D natin, ang 3/7D, no? Ito yung C, no? Considering the maximum strain that we can have. Minimum strain that we can have. Minimum steel strain that we can have. So therefore, we can conclude, no? We can say that our design, no? Could be really safe, no? Okay, ngayon meron na tayong value for A, no? We can be able to solve for the required steel area, no? C sub F is equal to T sub F, no? 0.85 F prime of C AB is equal to AS FY. Okay, 0.85, 27.5, 25.64, 2,900. Yung 2,900, no? That is the base, no? So balik tayo dito. Ito yung itsura niya, no? We assume that this is a cantilever beam and this is yung cross section of your beam. Okay? So going back here again, we are able to solve AS equal to 6,320.26 millimeters squared. Okay, no? So we all know that we have a required minimum, no, and maximum. We have required, meron tayong required na minimum reinforcement, no? So looking at the code, no, let's look at our NSCP code again, okay? Okay, so minimum area of flexural reinforcement AS min shall be provided at every section where tension reinforcement is required by analysis. AS min shall be the greater of A and B except as provided in 409.6.143. Statically determinate beam with a flange tension, the value of B sub W shall be lesser of BF and 2BW. Okay? No, so ito yung formula na pagpipilian natin. 0.25 square root of f prime of c over fy. B sub w multiplied by d. No? 1.4 over fy bwd. Okay, so let's go back to the part. No? So, AS minimum is equal to square root of f prime of c over 4fy. No? So, pareho lang yan dun sa pinakita kong code. No? Ang the one that I allowed you to have a photocopy, no, is the second print, no, second version of the printed NSCP 2015, the one I'm owning right now. Pero yung soft copy na meron ako is the first print, no, first print out, no, first set of prints for the NSCP 2015. Kaya medyo may differences between their variables. No, so dito, no, square root of f prime of c over 4fy b sub w d 1.4 over fy b sub w d, no? Yung dalawang formula na to, yung naka-bracket, no, they are called the raw minimum, no, or the minimum steel ratio. This is equal to square root of 27.5 over 4 times 275 times 2,900 times 525.71. This is equal to 7,268.05 millimeter square. Now, if we use the other formula, no, we are able to solve. We are able to get 87,761.39 millimeter square. No, so ang solved value natin for A sub S is equal to 6,320. So therefore, we supersede this value. And we use the minimum, no, which is equal to 7,761.39 millimeters square. Okay, and we determine the minimum number of bars, no, 7,761.39 over pi over 4. Dahil 25 millimeter diameter bars tayo, no, 25 square is equal to 15.81, 16 pieces. Okay, but wait, there's more, no? If we look at the detail, no, if we look at the detail of our reinforcement, no, yung kinonsider nating minimum depth na 525.71 is just the top bar. Ito yon, bali ito yon. Okay? No? From the center of yung mga pinarang pula na reinforcement up to the top of the footing, no? Up to the top of the footing, no? Pero what about this one, no? So this one, no, yung nasa ilalim niya, no, up to the top of the footing. So we determine the depth at the bottom, 525 plus 1.5 multiplied by 25, 563.21, no? So alam natin kanina, no, na if we redid yung pag-solve ng required AS, no, it's nothing compared to the minimum steel area. So we just use 1.4 over Fy BWD and substitute natin yung bago nating depth, no? 1.4 over 275 times 2,900 times 563.21, which is equal to 8,315.03 millimeter square. Determine the number of bars, 10.94 equal to 17. No? So, mas malaki yung mas malaki yung required number of bars natin sa baba compared sa taas, no? But on other practice problems that you're going to solve, no? Always consider the bottom depth na, no? Particularly lang naman when you are solving isolated square footings, no? Okay? So we proceed before we proceed, no? So ang masusunod na nating number of reinforcement, 17 pieces of 25 millimeter bar, no? On both sides of your footing, no? Okay? No? What should be the length, no? So we all know na meron tayong if we have the full dimension of the footing, we just reduce the concrete cover, which is 75 millimeter. No? So, ang magiging length niya, 2,900 minus 75 minus 75. So, just reduce 150 millimeter. That would be the length of your reinforcement on both sides. Okay. So, for sample problem number 2, no, we have two different dimensions, no? So for 4.8 meters and 3.2 meters long, no? And so therefore we are going to consider two different spans when determining the required steel area. Okay, so we try to determine first the minimum steel area on the short span. Okay, so short span, no? So therefore, assuming is your this is the front view of your short span. This is the 3.2 meter uh, long dimension, no? And 4.8 is the one that we cannot see. Okay, no? Equal to 3.2 minus 0.6 over 2, no? Is equal to 1.3 meters. O nga pala, no? Sabi din sa code, no, that this is also the critical section, no, for moment. No? So let's go back, no, to the codes, no, from section 413, no, location of critical section for MU, no, that is also a column, so face of column or pedestal, no. Okay, no, so and then I also indicated that along short span, no, the top bars are placed, no. So the longer dimension, nandun yung nasa ilalim, no, on the bottom. Okay, so therefore your MU now is equal to 271.88 multiplied by 4.8, no, it's this one. Okay, no, times 1.3, no, this one. Okay, squared over 2, no. So ang ginawa ko pala dito, no, we assume that this is a fixed support, no. So fixed support, then binaliktad ko lang. MU is equal to 1,102.24 kilonewton meter. MU shall be less than or equal to phi mn, no, the nominal moment. 1,102.74 times 1,000 squared, no, is equal to 0.89, 0.85, no, times 0.9. Now again, we came up with phi is equal to 0.9. We design it as a tension controlled tension control, no? We design our footing as tension control. 0.9 times 0.85 times 28 A 4,800, this one, times 611.74 minus A over 2. No, so 611.74, no? Saan nakuha yan? Dito. No? So we compare what we're able to solve, no, from minimum depth from one-way shear, long span 611.74, short span 78.70, two-way shear 497.18. So napapansin nyo na I decided to check the minimum depth against moment, no, kasi like what I said before, no, most of the deciding factors, no, the depth, no, mostly ang mag-govern sa depth, no, shear, no, shear will mostly govern, no, when considering the depth of our footing, no. So we decided to choose 611.74 as our minimum depth. Okay, so new thickness of our footing 611.74 plus 1.5 multiplied by 25 plus 75. Okay, next we your thickness now is equal to 724.24, which is also equal to 725 millimeter. Okay, so going back here, we are able to solve for value of A, which is equal to 17.78. So you can try checking, you can do the same thing, Pwede niyong gawin yung ginawa ko kanina on my previous problem, Pero ganun din naman ang lalabas. We'll know that itong value na to will be very safe, So now we use value of A, 0.85 F prime of C AB is equal to AS FY. And we have A sub S, which is equal to 5,887.5 millimeters squared. Okay. We check if it's within the minimum required reinforcement, just the same as what we did on the previous problem, square root of F prime of C, over 4 Fy BWD. We have 11,259.21. If we use 1.4 over Fy BWD, we have 11,915.63. So pwede nyong gawin na lang, these are your steel ratio, raw mean. N is equal to, dahil we know na yung compute nating AS kanina, didn't reach the minimum steel area, we use the one that governs 11,915.63 millimeters squared. Okay, so along short direction, we have 25 pieces of bars. Okay, so if we divide your total area by the area of 1 bar. Okay, next on the long direction, long span, so ganito pa rin yung itsura natin, pero 3.2 na itong base natin. Okay, 3.2 na ito. So ang nakaharap na tayo sa 4.8, ang value of x natin is still equal to, still equal to 4.8 minus 0.6 over 2, which is equal to 2.10. Okay, and we're going to use the new depth dahil nasa ilalim na siya, nakapatong siya, Okay. So nakapatong yung bar nakapatong yung 25 pieces sa taas, So, we have a new effective depth, no? 611.74 plus 1.5 times 25, no? So, I think I somewhat made a mistake here, no? So, dapat this is not 1.5 times 25, no? Okay? So, okay? Similar with the first problem. So, let me recompute this for you. Okay? No? So, 1 times 25. Kasi, no, ang detail natin, no, effective depth natin from top to ngayon, para maging, if we look at this section, no, if we look at this section and we want to consider the bottom bars, no, we will add half of the diameter here on the top and half of the diameter on the bottom. So, plus full diameter tayo instead of half only, no? Okay, so we will just add plus 25. Okay? Nga pala, no, yung mu natin is equal to 271.88 times 3.2 times 2.10 squared over 2, which is equal to 1918.39. We put it here, 1918.39 times 1000 squared is equal to 0.9, 0.8528, no? 3,200 times 611.74 plus 25 minus a over 2. We are able to have value of a equal to, I think this should be 45, no? This should be 45.58 mm. Okay, no? So 45.58 mm yan. And if we use 45.58 mm from the original equation, no, 0.85 f prime of CAB, 0.85, 28 times 45.58 times 3,200 is equal to AS times 345. That is equal to, no, this is equal to 10,061, no? 10061.95 mm squared. Okay, we check if it's within the minimum, if it's within the minimum required reinforcement, no? Square root of f prime of c over 4 fy, no? So square root of 28 over 4 times 345 multiplied by 3,200 times 611.74 plus 25. This should be the minimum AS is smaller than expected, no, 7,800 to 812, 7,812.89. This one. And then if we use 1.4 over Fy, 8268. Point 39. No? So we are going to use, no, 10,061.95 millimeter square. We determine the number of bars required, no? So we erase this one now. Okay. 1, 0, 0, 61.95. No? Over pi over 4, 10061.95 over pi over 4, 25 squared. We have 20.49, 20.5. No, which is also is equal to 21 pieces. No, so I guess it doesn't change much. No, doesn't really change anything. Pero we need to be very careful about it. No, so okay. For the previous problem, no, so I would want you to recheck uh, this one, no? So the depth should be new, 525 plus 25, no? So it should be equal to 550, I guess, no? 550. Okay, so if we use 1.4 over 275 times 2,900, 550, we have 8,120. 8,120. No? So this is the new value. Okay, determine the number of bar, 8,120 over pi over 4, 25 squared. Okay, so 8,120 din, 8,120 to. So let me erase this one. This is 8,120. 8,120. We erase this. It's equal to 16.54. Which is also equal to 17 pieces. Okay. No? So I corrected sample problem 1 muna, no? Pero wait, no? There is more on we have much more to do, no? Concerning rectangular footings, no? Okay? So if we look closely on the code, no? So okay, no? For there is an additional provision for two-way footings, no? Or yung rectangular footing natin. Okay? The design and detailing of two-way isolated footing shall be in accordance with this section and applicable provision of 407 and 408 sections. In square two-way footings, reinforcement shall be distributed uniformly across entire width of footing in both directions. In rectangular footings, reinforcement shall be distributed in accordance with A and B. Reinforcement in the long direction shall be distributed uniformly across entire width of footing. For reinforcement in the short direction, a portion of the total reinforcement SAS. Ang gamma S natin dito is not the unit weight of soil, no? It's just a symbol. shall be distributed uniformly over a band of width equal to the length of the short side of the footing, centered on the center line of the column or pedestal. Remainder of the reinforcement required in the short direction, now 1 minus gamma S AS shall be distributed uniformly outside the center bandwidth of footing, no, which gamma S calculated by gamma S is equal to 2 over beta plus 1, where beta is the ratio of the long to short side of the footing. Okay, so we have an additional provision for for we have an additional provision for rectangular footings, no? So ano ba yung ibig sabihin ng code na 'yon, no? So meron tayong tinatawag na center band, no, which is the same length as the short dimension of footing, no, located at the center of your column. No? So assuming that this is your column, no, we have the center band. No? We are going to measure 3.20, no, on the middle of the long dimension. No? So yung 3.20 nasa gitna, and the remaining, then what remains of the long dimension, no, are on the sides, no, and we are to compute, no, how much of the reinforcement on the short dimension should be placed on the center band, no? So using this formula, gamma S equal to 2 over beta plus 1, no, is equal to 2 over 4.8, the longer dimension, over 3.2 plus 1. No? So we have gamma S equal to 4 over 5, no, which is equal to 0.8. Okay? No? So ang area natin the center is equal to gamma S, no, 0.8 multiplied by 11,915.63. Okay? So yung area natin on the short dimension, no, this one. Okay? 11,915.63. Okay? Area on the center is equal to 9,532.504. And the number of bars on the center is equal to 19.42, which is also equal to 20 pieces. Okay? So we compute the remaining bars, no? The remaining number of bars, no, na ilalagay on the corner. And remaining over 2 is equal to 0.2, no? So 1 minus 0.8, no, times 11,915.63 over pi over 4, 25 squared plus 2. So therefore, it's equal to 2.42, meaning 3 pieces at each corner. So looking at this, no, we have at the longer direction, no. So meron tayong at this dimension, meron tayong 21 pieces na evenly distributed bars. Pero on the short direction, meron tayong tatlo on the corner, 1, 2, 3. And we have 3 also here. Pero on the center, we have 21 pieces evenly distributed on the center. Okay, so that's it for sample problem 2. And we're going to proceed with sample problem 3, which is wall footing. Okay, so for problem number 3, this is a wall footing. So we all know naman ang wall footing, we consider 1 meter strip, no? So the dimension that we cannot see here, no, the one on the side, no, this side, no, is 150. 1 meter rather, 1,000 millimeter, no? And this is the value of x is equal to the dimension, no, which is equal to 0.0 no, minus 0.25, no, over 2. Okay, that is equal to 275 millimeter. No, so we compute mu. Mu is equal to 160 kilonewton per meter squared. No, that is your QU multiplied by 1 multiplied by 0.275 squared over 2. No, yung formula na yan, that is from, if we assume it to be a cantilever beam. No, so nandito yung fixed support natin. No, like what we did on our previous problem. No, that is equal to 605 kilonewton per 6.05 kilonewton per meter. Okay, we put it here. M sub mu is less than or equal to m sub phi multiplied by m sub z. No, 6.05 multiplied by 1,000 squared is equal to 0.9. No, dahil tension controlled, times 0.85 times 21 times 8 multiplied by 1,000 multiplied by 168 minus, no? So, yung depth natin, we should modify this one, no? Okay? No, this is not 1.5, no? This is the mistake that I made on my previous problems, no? So, this is equal to 162. This is also equal to 162 minus a over 2. So, we resolve this one. 6.05 multiplied by 1,000 squared now is equal to 0.9 times 0.85 times 21 times x times 1,000 times 162 minus x over 2. This is, kaya kayo siya minumultiply ng 1,000 dahil siya ay uh, in kilonewton, no? Dahil siya ay in kilonewton per meter, no? I'm just going to convert it into newton millimeter. Okay? So we have the value of we have phi, no, we have a, no, rather equal to 2.34. 2.34 millimeter. We put the same value here. Huh? Okay, no? Okay, so therefore that is equal to 0.85 times 21 times 2.34 times 1,000 is equal to AS times 420 is equal to 99.45. Okay. $99.45. Okay, no? So we check if within the required minimum area, no? So according to section 407.6.1.1 of the NSCP, no, considering one-way slab, no, we are analyzing it as one-way slab. So I think it's not here, no. So let me let me let me search it from the NSCP, no? Okay. This is it. Okay. Okay, so uh, main main reinforcement, no, the minimum area, minimum AS is equal to, no, for deformed bars, no, less than 420 megapascal yung FY natin, no, 0.0020 AG. The AG here is the area of your concrete. No? For greater or than or equal to 420, we choose between 0.0018 times 420 over FY AG or 0.0014. Okay? So let's go back here. No? So we compared these two, okay? No, so formula A 0.0018, no, times 420 over Fy, no, for times 420 over 420 times 250,000, okay? Or 0.004 AG, no, 0.0250,000. Ang AG natin, gross area of the concrete section, 1,000 multiplied by 250. No? Okay? Ang AS mean natin for formula A is 450 millimeters squared and B 350. So, understood na ang mag-govern dyan will be formula A. So, we determine the number of bars, no? 450 over pi over 4, 12 squared. 3.98 which is equal to 4 pieces. No? So, pasok siya sa minimum steel area, no? But we have to check the spacing as well, no? The spacing of your rebars. Okay? So, S is equal to 1,000 kasi we assume uh, 1 meter strip, no? We divide it by 4, no? It's equal to 250 millimeter. And now we check your minimum and maximum spacing, no? From section. For minimum spacing, determinan muna natin yung maximum spacing first kasi that is our priority. Okay? That is our priority, no? We need to Okay, for section 407.2.3, no, maximum spacing of the deformed reinforcement, no, shall be lesser of 3H and 450 millimeter. Okay, that is applicable for those are applicable for non-pre-stress slabs. No? So 3H, 3 times 250, 750 millimeter. B, 450. Maximum is 450. No? Maximum is 450 millimeter. No? So maximum is 450 millimeter. So we follow this value. Okay? And 250 millimeter is within the maximum spacing. Check naman what should be the minimum spacing. Although only rare cases na it's becoming below the minimum. No? From section 425.2.1. Okay. Section 425.2.1. From section 425.2.1, no? So we have here, no? The minimum spacing of reinforcement, no? Okay? So let's go back here, no? So we compared it to the with the maximum value 3h 3 times 250 is equal to 750. B is 450. 450 is the maximum. 250 is below the maximum value. Now let's look at the minimum using section 425 of your NSCP. Okay. Parallel non-pre-stress reinforcement in a horizontal layer, clear spacing shall be the greatest of 50 millimeter diameter bar and 4/3 of the diameter of the aggregate. Now, so since we don't have the diameter of the aggregate, we can actually neglect this. We just compare 50 millimeter and the diameter of bar. Okay, next we going back to uh, going back. Okay, no, 20 millimeter and 12 millimeter. No? So, since minimum ang kailangan natin, no, the minimum is 25 millimeter and our computed spacing is just okay. Next, of course, we need kailangan natin ng tinatawag na temperature reinforcement. Okay? Or yung transverse bar. No? According to section 424.4.3.2. Okay? Four point four to 4.4.3.2. Minimum. Okay, minimum area for temperature reinforcement, no? Greater than 420 megapascal ulit tayo. So this one, no? Just the same as our formula, the one that we use above, no? So let me show you that. Okay? Okay, so that is greater between 0.0018 times 420 over 420, no? Gross area, no? Times 800 multiplied by 250. Bakit 800 times 250? No? Kasi we assume na ang longer dimension na niya, yung 1 meter. Nakaharap na tayo sa 1 meter. So ang base width na niya is equal to 800 yung dimension na na-compute natin. Okay? So minimum is 360 millimeter squared. No, 360 over the diameter, the area of bar is equal to 3.18 is equal to 4 pieces. Okay, we compute the spacing, the required spacing, no? 800 minus 2 times 75, which is the concrete over 4 is equal to 162.5. We round it up to the nearest 5 millimeter equal to 165 mm. Minimum and maximum spacing, no? Similar to what we did earlier, no? 25 millimeter, no? And dB is equal to 12 millimeter. Pasok pa siya sa minimum. Pero on the maximum, no, we have a slightly different approach, no? Iba ang maximum spacing kapag ibang maximum spacing for temperature reinforcement ng ibang maximum spacing niya, no? So let's look again at the code. Okay? Iba ang spacing ng code, iba ang spacing natin for temperature reinforcement, no? So what is the minimum spacing for temperature reinforcement? Okay, so here it is again. Okay, the spacing for deformed shrinkage and temperature reinforcement shall not exceed the lesser of 5H and 450 millimeter. So ang H natin pala dito is the thickness, no? Yung thickness na computed natin. Okay? So 5H, 5 times 250 is equal to 1,250, and then 450. Within 450 millimeters, so pasok naman siya. Pasok naman yung computed spacing natin. Okay? Hmm. So again, no, bakit ko nga pala pinili itong formula na to, no, in solving for the moment, no? Kasi ah yeah, personally, no, mas madali siyang tandaan, and somewhat you are going back to what we've learned from your RCD. So medyo two birds with one stone na. Although other variables are just additional, no? Pero ito yung pinaka-basic, no? Yung we don't have to memorize other things, no? Okay. So, pero it's much better pa din if uh, you are able to know many approach, no, on how to solve. Okay. And that ends our video, no? So for any questions, no, don't hesitate to uh, message me, no, anywhere, no, uh, on my social media, no, or on Blackboard, no, and also uh, you can also leave some comments, no, and I will try my best to answer it right away. And also for more updates, no, kindly like and subscribe, no, as well as check your Blackboard din, no. And on our next video, no, medyo we are almost done, no, on designing our footings based on the three problems that we've solved, no. So brace yourself, no, as we uh, end this series, no, this video series. Okay, thank you very much. See you next video.